Hello dear students, today's lesson is square roots and cubic roots, page 10. Definition, objectives, definition, example 1.2, page 10, and then exercise 1.2. Definition, square root of a number x is y such as that y multiplied by y is x. Of course, y is under the root square. For example, when x equals 100, the square root of 100 is 10, just like when y equals 10. So this number inside, I like to say to you that this number inside comes from a number multiplied by itself 2 times. Okay, so when I take the square root of it, it will give me an integer, a whole number. This is a whole number, okay, an integer, a whole number under the root square. So if this one is not a number multiplied by itself, you cannot take the root square. If you take the root square from it, it will give you also the same thing, decimal or a fraction or something like that. But only when it is a number multiplied by itself, only then it can give you an integer or a whole number. And this is called the square root of this number. The square root of this number is half of it outside. Like we shall take in examples, like 4 equals 4 times 4. So you see, it's a number multiplied by itself. 4 times 4 is 16. Square root of 16, only the square root, not the cubic root. Only the square root of it will give you half of it, which is 4, one of them, you know. One of these numbers. It will give you out the one of these numbers, because it's a square root. So when I say square root, these numbers should be multiplied by themselves 2 times. When I say cubic root, these numbers have to be multiplied 3 times by itself in order to give you one of them outside as a real number or a whole number. So if you like to take the square root of a number, they have to be multiplied by themselves 2 times, okay? If you have to find the cubic root of a number, they have to be multiplied by themselves 3 times. In both situations, in order to give you a whole number, not a decimal. This is another example, this is another example, and this is another example. As you see, they are all the number multiplied by itself, and it is the square root. By the way, when you see nothing written here, nothing, that means it is 2 square root. And the number here inside should be coming from a number multiplied by itself. 20 times 20 is 400. So it should be here 400. If 400 comes from 20 times 20, a number multiplied by itself, so that you can be sure the answer will be a real number, a whole number, called what? Called 20. Not a decimal, not a fraction. The cubic root is the same, but it's not 2y's multiplied, it is only 6y's. Make it very short, is also the same. X equal the cubic root of y multiplied by y. We need here a 3 now. When you see a 3 here, that the number inside must be multiplied by itself, not 2 times, no, 3 times. Why? In order to give you an integer or a whole number. If it is not by itself 3 times, it will give you what? Not an integer, not a whole number. It will give you a decimal, something with points. When you take the cubic root of a number, in order to have a real number, integer as a result, the number inside the cubic root must be multiplied by itself 3 times. Like this one. 10 times 10 times 10, cubic, give you 10. If I say here, just like square root, 10 times 10 only, and take the cubic root, it gives me a decimal. Why? Because the condition to take the cubic root of a certain number is that this number must be multiplied by itself 3 times. The same goes for the 4th cubic or the 5th cubic for a number. Okay, 4th cubic for a number, the number must multiply by itself 4 times. The 6th root for a number, the number inside must multiply by itself 6 times. The 10th root for a number, the number inside the root must be multiplied by itself 10 times. In order, all that y, in order to have a result from this root type, a whole number or an integer. If it's here written like that, 10 times 10 times 9, 10 times 10 times 9, it will not give you an integer or a whole number. It will give you a decimal. But I want a real number, so the number inside must be multiplied by itself 3 times. Okay, this one is another example. You see, 3 times itself, cubic, you have to, so that you can have 5. The whole number or an integer. So these must be multiplied by themselves 3 times in order to have a whole number or an integer. Okay, question number 1a, the questions in the book is like that. I want you to do something like this here. The root square of 8 Where is it? Because I don't know the root square. You don't have to find the root square first. You have to find the position on the line number. Where is the position of the square root of 8? The square root of 8 is in fact 2.8. And you don't have to find 2.8. You can write here only square root of 8. And it is between 2 and 3. How did I know it is between 2 and 3? Because take the 8 out. Take the 8 out as a number. And find what are the closest numbers for 8 from the left and from the right. Start from the left always. We take 2. 2 times 2 is 4. 4 is the closest number to 8 from the left side. If you tell me, sir, why don't you try 3? I tell you, okay, 3 times 3 is 9. 9 is bigger than 8. I want something the closest to 8 from the left side. So if you find 2 is the closest, the next number will be 3 automatically. Don't think which number, 4, 5, 6. No, it's 3. When 2 is from the left, then 3 is from the right. So 3 is 9 from the right, and 4 is from the left. So I can say that really, the square root of 8 lies between number 2, this one here, and 3. 2 and 3 on the line number, not the result of them. No, from this one here, the integers 2 and 3. So between 2 and 3, of course, this square root lies somewhere between them. Okay, you don't have to locate me very good. Only you say square root of 8 is here. The same situation is for this question here. Take the 20 out, and then try 2 and try 3 and try 4 and try 5, multiply them by each term. See if this number comes very close to 16 from the left side, but don't go over 16. So I find that 4 times 4, 16 is the closest number to 20 from the left side. What is the next number? 5. Immediately say 5. You don't have to think about it, okay? So 16 and 25 are the numbers which are surrounding from the left and the right number 20. So the square root of 20 lies between 4 and 5. Square root of 20, I did find the answer here to make it more accurate, but you don't have to find this answer here. You can only say that the square root of 20 lies between 4 and 5. It is bigger than 4. This is what I want from you here, this expression, that the square root of 20 is between 4 and 5. Exercise, the same situation for exercise y. This cubic root is between 6 and 7. This is the same question as the last one, but he expressed it in another way. Also go trying 2, 3, 4, 5, 6 until you find a number which is closest to 305 from the left side, and of course when you find the 6, immediately you know that this is 7. So 7 times 7 times 7 is 343. Number 216 is the closest to 305 from the left side, and number 343 is the closest to number 305 from the right side. So where does the location be from cubic root of 305? Where is it? It is between 6 and 7. Very easy. Between 6 and 7. Somewhere here. I don't care where, but somewhere here, okay? Say somewhere here. Important you show me. You can write this as an expression, like you say the cubic root. So the cubic root of 305 is bigger than what? Is bigger than 6 and smaller than 7. You can write this also. The cubic root of 305 is bigger than 216 and bigger than 6 and smaller than 7. Or you can draw the line number as it is here. Exactly for this one, the same story. Take 171 out and find the numbers from the left and the right. You see y from the left and the right. I found that 13 times 13, 169 is the closest number to 171 from the left side. Okay, when I know that 13, which is the next number, I immediately say 14. Don't go thinking which number. When you find that the 13 is the first one, the next one will be exactly the next one. So 13 times 13, if you take 14, 196, this went over 171. It's not the closest from the left. The closest from the left side is this one here, and the closest from the right side is this one. So the square root, this is also the same for the square root for 171 is bigger than 13, smaller than 14. The same goes for 3b. Also the same story. You choose a number which give you the multiplication of it, a number which is closest to 26.3 from the left side and from the right side. Don't let the point here make it hard for you. Just ignore it. Just 0.3 or 0.7 or 0.8 or 0.003. What is the value of that? Have no value. Okay, we are not so. I wouldn't say that these numbers have no reason, but they want you to understand that it is 26. 26 is just like 26.001 or 26.3 or 7 or 7. So it is 26. Find the number from the left side and the right side. Okay, from the left side, 5 times 9, 25. This is the nearest number to 26 from the left side. 6 times 6, 36. It is the nearest number to 26.3 from the right side. Okay, so you can say square root of 26.3 is bigger than 5, smaller than 6. Okay, this is the same questions, but express it in another way, but it's the same procedure. Okay, now we have cubic root of this guy. The same story. So take this out, take the 58.8, take it out. Now you need a number from the left side is closest to this one, and from the right side. From the left side, because it's cubic, look, cubic, you have to multiply 3 times. 3 times 3 is 27. 27 is the nearest number to this one from the left side. And from the right side, it's 4 times 4 times 4, which gives me 64. 64 is the nearest to this number from the right side. You see why I didn't choose here 4, because it would go over 58. So I go a little bit lower, 3. 3 times 3 times 3 give me 27. This is the nearest from the left, this is the nearest from the right, and this is 27 nearest from the left, 64 nearest from the right, and the expression will be written like this: cubic root of 58.8 is bigger than 3, smaller than 4. This is what I need as an end result of the solution. I don't know how much is the cubic root of 58.8. I don't have a calculator, but I'm sure it is bigger than 3 and smaller than 4. This is the aim from such questions and such methods. Okay, now we go to exercise 1.2. He said to you, what's the difference? What is wrong? What is this guy speaking about that the square root of 16 is the same as square root of 160? No, exactly not. Square root of 16, it comes from 4 times 4, and this is give me 4. This is correct, yeah. But 160 comes from 4 times 40. 4 times 40, it is not a number multiplied by itself. It is a number 4 multiplied by 40. So 4 is a number and 40 is another number. They are not the same number, okay? They are not the same number. So it is really wrong. The answer is here wrong. Of course, the answer will be here wrong, because the square root of 160 will be 12.649. You see? Point. The result of this square root will be a decimal. And it is why? Because the number is not multiplied by itself. So this answer 40 is wrong. This answer is correct because it's multiplied by itself, is correct, but this is wrong because the square root here, the number here, is not a number multiplied by itself. And the answer would be a decimal, not 40. Okay? This is exercise. This is homework. I wish you can make exercise 1.2, number 1 and number 4. Okay, thank you very much for your attention.